Another way to achieve thread safety is by using the atomic classes in Java. So in this package, we have a bunch of atomic classes like atomic boolean, atomic integer, atomic long, and so on. With these atomic classes, we can perform atomic operations. For example, earlier you learned that incrementing a variable in Java is not atomic because it involves three instructions: get, increment, and write. With these atomic classes, we can increment or decrement a value in an atomic way. Let me show you. So in our demo class, we have the same code as before. We have a single status object that we're sharing across many different threads. Over here, we're creating 10 download threads. Each thread downloads 10,000 bytes. So once we join with all these threads and print the total bytes, we expect to see 100,000 on the terminal. Take a look. We don't see that, so we have a race condition. Now, to solve this problem, we go to our download status class. So here we are not using synchronization, we are not using logs, we have a very simple class. Now, to solve this problem, we need to change the type of this field from int to atomic integer. And then we set this to a new atomic integer. Now, in our getter, we should return total bytes.get. This will return the actual value. And in our increment method, instead of the increment operator, we call increment and get. We also have get and increment, which returns the value first, and then it will increment it. So more accurately, increment and get is equivalent to plus plus a, where a is our variable, and get and increment is equivalent to a plus plus. Now in this case, we don't want to return this value, we just want to increment it. So it doesn't really matter which method we use. So I would prefer to call increment and get because the intention is more clear. So that's it, that's all we had to do. Now, multiple threads can modify this field concurrently without waiting for each other. Let's run the program and verify this. So take a look. There you go. We got 100,000. Now, if you're curious how atomic types work, they actually use a technique called compare and swap, which is supported by most CPUs. So most CPUs can execute this operation as a single uninterruptible operation. So when we call the increment and get method, this atomic type is going to compare the current value with the expected value. If they're not equal, it's going to swap them. For example, let's say the current value of total bytes is 0. And we want to increment it. So the expected value is 1. Now this atomic type is going to compare these values. Because they're different, it's going to swap them. So 1 and 0. Now this entire operation is natively supported by most CPUs as an atomic operation. So if you're dealing with counter variables, prefer atomic types to synchronization because they're faster and easier to use.